So very good afternoon to all of you, and today I am Sachin Singh, and today I will teach on the topic of designing climate resilient agriculture system under rainfed ecology. So we move to the first topic, and these are the outline of my topic that cover the introduction, then why climate resilient agriculture means need of the climate resilient agriculture, and what is the climate resilient agriculture. After that, the concept of the climate resilient agriculture, and then approaches and practices which use for climate resilient agriculture. So this slides so that the define the what is rainfed agriculture. So area where irrigation facility less than 30% and rainfall more than 1150 mm. This area is known as rainfed area, and agriculture production of crop in this area is known as the rainfed agriculture. So as we know that the net sown area in India is 141 million hectare, and 51% of the net sown area under the rainfed agriculture. And this rainfed agriculture account 40% of India total food grain production. So we then we know the characteristics of the rainfed agriculture. So first of all, in rainfed agriculture, there are frequent dry spell during the crop season, then early withdrawal or late onset of the monsoon. This is also common feature of the rainfed agriculture. Then crop failure is a very common because there are deficiency of the rainfall at any time, and also inadequate and uneven distribution of rainfall. And in this area, there are also very low soil fertility and low level of ultimately this lead to the low level of productivity. And this slide show the contribution of the different sector of in climate change. So there are in this slide we can see that energy sector that contribute the highest on the global warming, that is 35%, and then after energy sector, agriculture sector cover the 24% of the total climate change, and then industry sector that is 21%, and then transport, and after that building sector that is the 6%. So agriculture accounted for approximately 43 and 47% increase in the nitrous oxide and methane emission respectively as compared to 2017. And then mainly methane and nitrous oxide through livestock, irrigated rice field, and application of nitrogenous fertilizer. And this is the area that cover the rainfed agriculture, and we can see that the trend of long term that is the 50 years before mean annual temperature trend in 47 location of the India. So we can see here how in some area there are increasing trend, and in some area there are decreasing trend of rainfall. So in this slide so that why climate resilient agriculture means need of the climate resilient agriculture. As we see that continuously rise in the greenhouse gases that decrease in the photosynthesis and growth of the crop, and it also leads to rise in the temperature that reduce the growth and productivity of the crop, and rise of the temperature also lead to melting of the glacier that reduce the water storage, as well as it also reduce the net area of the crop, and it also raise the sea level, that sinking of the coastal farming also, and changes in the rainfall pattern, and if rainfall pattern change that occur that lead to drought or flood and reduction in the water availability. So in this slide we know the what is climate resilient agriculture. So climate resilient agriculture means the incorporation of adaptation, mitigation, and other practices in agriculture which increase the capacity of the system to respond to various climate related disturbances by resisting damage and recovering quickly. And here there are images that are the tool for use in the for climate resilient agriculture. Then that is the adaptation and mitigation to the climate change, means there are some strategy that used for adaptation and mitigation of the climate change. So first of all, adaptation. So crop has to be more resilient to drought, flood, heat, cold, and pest. And in case of the mitigation, there are crop has to be more efficient in water use, fertilizer use, and energy use. So there are approaches and practices for the climate resilient agriculture. And there are various practices like the agriculture resilience by increasing the production, by raising the farmer income, ensuring food security, adapting climate smart agriculture, and for reduction of the greenhouse gases, that is adopting the clean energy, effective crop management, enhancing the quality of livestock farming, and for increasing the forest cover, that is the agroforestry area, and social forestry, indigenous tree plantation, joint forest management, and for least land use change, that use the maximizing the maturity of the land, naturality of the land area, and also allow least change and adapting the practices of the sustainable development. For the water management, they are increasing the storage capacity, fair policy for water supply and distribution, river health and watershed management, treatment, alternative source of water. Then crop diversification. So first we know what is crop diversification. So addition of the new crop or cropping system to agriculture production on the particular farm, and there are various benefits of the crop diversification, that is the raising farm income, sustainable production and income, food and nutrient security, carbon sequestration, risk reduction, and indigenous use of land and water resources effectively, and ecological balance. Then aqua sowing. So these are the aqua seed drill that used for the aqua sowing, and sowing the seed with the required quantity of the water, and then particularly in the rain-fed Rabi crop, because in Rabi crop there are no rainfall occurs, and drilling of the water in the vicinity of the seed zone. And there are various advantages, that assure supply of the moisture, improve germination of the seed, 20-25% of the yield increase, and increasing the nutrient use efficiency. Then water management. So there are two types of the method are used for the water management, for the water harvesting as well as recycling of the water. That is the in situ moisture conservation. In case of the in situ moisture conservation, there are broadbed and furrow method used, interplant water harvesting method used, and scoop and dead furrow making. For ex situ water conservation, there are farm pond, dug well, and tank. And here also use mulching for the water conservation, that reduce the evaporation of the water from the soil, and also use drip irrigation. Drip irrigation increase the efficiency of the water by 90%, and also conjunctive use of the surface and groundwater, and supplemental irrigation or life saving irrigation given during the drying of the crop, and efficient use of the irrigation water by adopting drip method of the irrigation. Then mulching. So layer of the material supplied on the soil to cover it is known as the mulching. There are various advantages of the mulching in the climate resilient agriculture, that is the increasing the soil moisture by reducing losses from direct evaporation, moderate soil temperature by keeping the soil warmer during the cold night and cooler in the hot day, reduces irrigation requirement, and also reduce the weed growth by restricting light from reaching the soil surface, that reduce the evaporation of the water from the soil. Then polymer in agriculture. Polymer also used in agriculture, and there are two types of the polymer used in agriculture, PUFA hydrogel and PUFA gel shakti. So in case of the PUFA hydrogen, that is the natural polymer and maximum absorption at 40 to 50 degrees centigrade temperature, and absorb water 400 times its dry weight, and stable in the soil for the 1 year and less affected by the salt. And there's gel shakti increase the soil physical properties when mixed with soil, and advantage improve the physical property of the soil, improve the germination and emergence, delayed onset of the permanent wilting points, and reduce the leaching of the herbicide and fertilizer. Then this slide shows the nutrient management. So for the climate resilient agriculture, we use the site specific nutrient management. There are three principles of the site specific nutrient management. That is the first, establish the target yield, means what yield I want to achieve. And the second step, effectively use of the existing nutrient, means the nutrient which available in the soil and also given by the manure are available in the crop residue, that utilize effectively. And then last step, that is third step, fulfillment the gap between the existing nutrient and need of the crop by nutrient, and the nutrient fulfillment by the tool that is used for the site specific nutrient management, and that is the chlorophyll meter, also known as the split meter, and then leaf color chart and green seeker. And the source of the nutrient, that is the FYM, green manuring, inorganic fertilizer, biofertilizer, etc. And then weed management. That weed management is also one of the most important operation in agriculture. And for climate resilient agriculture, there are three methods available for the weed management. First one is the brown manuring. And in case of the brown manuring, we rice co-culture with the susbania and knocked down by the 240 and in 25 to 30 days after sowing. And this help in reduce the population of the weed by early covering cover of the canopy, and it also fix the atmospheric nitrogen which increase the nitrogen level in the soil, and it also work as a mulch. Then smoother crop. Smoother crop is a quick growing crop which early cover the soil surface and reduce the germination of the weed. And the example of the smoothing crop is cowpea, horse gram, mung bean and maize. And then herbicide resistant variety in the DSR. So there are various type of the herbicide resistant variety that is produced by the IRI. These variety are the Pusa Basmati 1979 and Pusa Basmati 1985. That is resistant to the imidazole herbicide. So next is the conservation agriculture. In conservation, there are conservation agriculture, and this conservation agriculture is based on the three principles. That is the crop diversification, and second one is the minimal soil disturbance, and third one is the soil cover with the residue. So in case of the crop diversification, we have to select different type of the crops in a particular area, and rotation of the crop is also followed in this area, and there are various benefit of the crop diversification. Like this reduce the pest and disease incidence in the crop, because intercropping or crop cycle are follow, and the survival of the particular disease or pest is not occurs in other crop. And second one is the this also control the weed, because particular weed are grown on the particular crop, and if we change the cropping system or if we change the crop, then weed will also be changed, and so it also help to reduce the weed. And third one is adequately distribution the nutrient in the soil, because in crop diversification also added legume crop that fix atmospheric nitrogen, and it help in increasing the nitrogen level in the soil, and also it improve the soil microbial physical as well as the chemical property of soil. And then it also reduce the economic risk, because if one crop failure, then other crop recover the risk of the failure of the first crop. And then there are another benefit that allow the balanced residue production, because in conservation agriculture residue require more. So if we follow the crop diversification, this also produce more residue production. And then it also reduce the climatic risk. Climatic risk, because if suppose that if rainfall occur and one crop damage, then another crop in the same field also that is resistant to rainfall or waterlogging, so that crop survives, so it reduce the risk of the crop failure. Then second principle explain the minimal soil disturbance, and for minimal soil disturbance we follow the zero tillage practices. And in there are various benefit of the reduced tillage, that is it avoid the compaction and soil surface sealing. Means if mechanical tillage apply in the same field in repetitive manner, it develop the hard pan. But in case of the zero tillage, there are no tillage operation required, and tillage is done only on the row zone. So the risk of the compaction of the soil is reduced. It also reduce the erosion, because there are less disturbance of the soil, so erosion will also reduce. And it also reduce the greenhouse gases, because minimal soil disturbance, there are no requirement or less requirement of fossil fuel or diesel that not burn, and it help to reducing the greenhouse gas emission. And it also improve the soil fertility and surface structure, because soil are less disturbed. And then it also increase the biological activity as well as the soil organic matter. Then we go to the soil coverage with the residue. So in case of the conservation agriculture, there are at least 30% soil covered with crop residue, means 30% residue covered by the soil covered by the residue. So here crop residue help in higher water infiltration, and also it reduce the evaporation of the water from the surface of the soil to atmosphere. It also help in reducing the erosion of the soil, like the wind erosion as well as the water erosion, and it also moderate the soil temperature. as well. So these are the conservation agriculture that must be used in the climate resilient agriculture. Then there are the resource conservation technology. So in conventional method, there are highly dependent on the mechanical cultivation, but in case of in case of the resource conservation technology, there are the zero tillage and leisure land leveler adopt. So here zero tillage help in 90% reduction of the erosion, and also it increase the 0.1% per year, 0.1% ordering matter per year in top 2 inches of the soil. And here in case of the leisure land leveler, it also help in reducing the 20-25% of the water requirement by the crop, and it also increase the 2 to 3% increase in the cultivable area. Then agroforestry. So now first we know the definition of agroforestry. So it is the self-sustained land management system which combine production of agriculture crop with tree and livestock simultaneously or sequentially on the same unit of the land. And here various benefit of the agroforestry, like it reduce the soil erosion, and it also provide the organic matter and biomass generation, and it help in the carbon sequestration also, and it provide the shelter of the livestock and pasture provide, and it also give the shelter of the wild animal and birds, and shedding effect also provided by the agroforestry. And it if legume crop taken as a component of the agroforestry, it also help in increasing the nitrogen level in the soil by fixing atmospheric nitrogen, and it also help in increasing the moisture level and nutrient level in the soil. And the major benefit of the agroforestry is the nutrient recycling. Means agroforestry tree crop absorb the nutrient from the lower soil layer, and after setting of the leaf, that this is composed with the nutrient, and it after decomposition it release the nutrient on the surface layer of the soil, and which absorbed by the cereal crop or other annual crop. Then carbon sequestration. So here first we know what is the carbon sequestration. So carbon sequestration is the method where the green plant absorb CO2 from the atmosphere, and CO2 is a toxic and greenhouse gas. That is the major contribution of the greenhouse gas. So greenhouse gas absorbed by the green plants by the process of the photosynthesis and used as a carbohydrate. And after absorption of the greenhouse gases by the plant, means CO2 absorbed by the plant, it store itself on the as a biomass, and after harvesting of the plant, it decay on the soil. So it help in reducing the CO2 from the atmosphere. So this is process known as the carbon sequestration. And here we can see in the diagram of the carbon sequestration. So it capture and secure the secured storage of the carbon into the long-lived carbon pool, and the total potential of the soil carbon sequestration in India is 39 to 49 decagram per year. And there are the various methods or various components used in the carbon sequestration, that is the agroforestry, natural farming, zero tillage, crop cover and mulching, manure management, avoiding soil erosion, organic farming and high biomass farming. So these are my presentation and my class. So thank you for listening.